Well, dear friend, there are some questions again based on the parallel combination of resistance and cells. Here is a diagram. Here you are asked here I1, I2, I3. And yes, I1, I2, I3. E1 2 volt, R1 1 ohm, this E2 1 volt, R2 1 ohm, this R is 2 ohm. So now we can redraw this diagram as this diagram. This diagram can be redrawn. Can be redrawn. How? Actually, these two batteries are in parallel. This R1 and R2 are supposed to be internal resistance, and this is R here. This is R equal to 2 ohm. This is R1 1 ohm. This is R2 1 ohm. E1 2 volt. E2 1 volt. Find I1, I2, I3. I1 and I2 and I3. So these cells, a simple way to solve this problem, to find I1, I2, I3. We have learnt if two cells are connected in parallel, having internal resistance R1, R2, E1, V1, and E2. So E equivalent equal to E1 R2 plus E2 R1 upon R1 plus R2. So it is here E1 2 into 1 plus 1 into 1 upon 1 plus 1 2. So it is 3 upon 2. 2 1 got 2 plus 1. Right. 1 into 1, sorry. So it is 1.5 equal to 1.5 volt. Equivalent EMF. Equivalent resistance will be, they are in parallel. So R1, R2 upon R1 plus R2. It will be 1 1 upon 2, 0.5. So we get here a battery of EMF this, internal resistance this, and external resistance R equal to 2 ohm. So we know I equal to E upon R plus R. Okay. So I3 equal to 1.5 upon 0.5 plus 2 ohm. Okay. So it is how much? 1.5 upon 2.5. 15 upon 25. 0.6 ampere. So simply use parallel combination of cells. Actually, some author represent internal resistance this side generally, but it can be here also. These R1 and R2 are treated here as internal resistance of cell. Now, how to find I2 and I1? I2 and I1, we know when current is drawn from cell, V equal to E minus IR. For I1, टर्मिनल वोल्टेज जो V होगा, that is V equal to I3 into R, यानी कि 0.6 into 2, 1.2 volt potential difference, and they are in parallel. So terminal voltage of each battery, hence terminal voltage of each battery या each cell equal to 1.2 volt. EMF 2 volt, it is 1 volt. Now for I1, V equal to E1 minus I1 R1. 1.2 equal to 2 minus I1 into 1. So I1 equal to 2 minus 1.2. It is 0.8 ampere. 0.8 ampere. Then for I2 again, for current I2, V equal to E2 minus I2 into R2, 1.21 minus I2 into 1. So I2 equal to 1 minus 1.2. 1 minus 1.2. अभी क्या हो जाएगा? 1 minus 1.2 is equal to minus 0.2. 0.2 minus this angle. Minus sign means current will pass through this. E2 will take current. Minus again, negative sign means a cell of 1 volt will take current, not give current of 0.2 ampere. So this way, this question has been asked in board also. So I have done this by using equivalent EMF of cells in series. है भाई, ये थोड़ा उधर हो गया. Have you got my point? Now question number 2. Yes, there are 2 batteries, each of EMF same E and resistance same R. R equal to 1 ohm. When 2 batteries of same EMF and same are connected in series across a resistance R, E1 ohm, E1 ohm, they are actually identical battery cell. So they produce power J1 when current parallel in current taking from that produce power J1. Now when we connect them in parallel, then power here R across R, power equal to, I can say this is power P1 J1 and P2 equal to J2, such that J1 and here it is J1 equal to 2.25 J2. What is R? You are asked what is R. I have got my problem. EMF P, E, R, they are connected series. They produce power, heat rate of loss of heat is J1 in R. When current parallel, then power produced heat loss, heating power produced on R is this. What is R? Question है, what is R? You may feel some difficulty in understanding, but when you solve it again and again and more question, you will find they are nothing. So power produced है, you know the formula is I square R. Simple बात है ना. So how much current will be drawn in figure 1? Figure 1, figure 2. In figure 1, I equal to 2E upon R plus 2R. 2E है बस, and hence J1 और produce I square R यानी के 4E square R upon R plus I square R. I square R. I square comes 2E upon R plus 2 whole square into R. Or you can write J1 equal to 4E square upon R plus 2 into R. Power produced by heat produced I square RT, and power rate of work done, power upon time to I square R formula. I have told this thing. Now in figure 2, I will be equal to, in parallel potential difference remains same. Equivalent resistance will be 1 by R plus 1 by R, यानी कि 1 by 1 plus 0.5. In parallel, here terminal potential same. So I equal to E upon this R plus 0.5. What is 0.5? Equivalent resistance of these two R1 ohm है ना, है भाई, and hence J2 है भाई. अब J2 क्या होगा? Power produced J2, this I square R यानी कि I E square upon R plus 0.5 whole square into R J2. तो J1 upon J2 करेंगे हम, है भाई. Now J1 upon J2. 4E square R upon R plus 2 whole square. sorry हो जाता है स्क्वायर into R. उल्टा कर दो इसको डिवाइड के लिए, R plus 0.5 R स्क्वायर है भाई 0.5 अपॉन E square R. E square R कैंसिल, तो J1 अपॉन J2 0.5 है. J1 upon J2 0.5, but this is 2.25 equal to 4 R plus 0.5 square upon. Children remain in hurry. They start opening A plus B whole square. No need. This is perfect square, perfect subperfect square, taking root on both sides. 1.5 is the square root of this. 2 into R plus 0.5 upon R plus 2. And from here you can get R. 1.5 R plus 3 equal to 2 R plus 1. Or what is this? 2 minus 1.5 R equal to 2. R equal to 4 ohm. So please don't avoid difficult questions. By solving difficult question, you will get the subject very easily. This was second question. Now third question is there. Here I have to select the question from question banks, which are asked in board exam as well as in competitive exam. I'm observing that viewers are now decreasing. I don't know why. Please start working hard from this time. Don't think that we will do it later on. So here there is another diagram here. The battery of E, internal resistance R. This is R, and here is capacitor, and internal resistance R1, and this is R2. This is R2. Now you are asked when in steady state in the circuit, in steady state, what is the amount of charge on capacitor? Steady state means actually when we will switch off on the circuit, charging of capacitor will take place. So current may flow in this branch also and this also. But when it will get fully charged, no current will be disarmed. In steady state, no current will flow in branch of circuit, in branch containing capacitor. This fact you can realize. So then current will continue to flow here. And how to find charge on capacitor? If you remember definition of capacitance, Q is equal to CV. Q is equal to CV होता है. So you need potential difference across this or this. When they are in parallel, तो potential difference across R2 का IR2 होगा. Then in steady state, how much current is flowing in here? Current will flow only this direction. So that I here in steady state, I equal to E upon R2 plus R. R2 plus R. This is R here, mutual resistance. And hence potential difference across R2. Potential difference across capacitor. No current flow, so this has no meaning here. Equal to potential difference across R2 equal to IR2, यानी कि ER2 upon R2 plus R, and hence charge on capacitor Q बराबर C, so it is CE R2 upon R plus R2 is the charge on capacitor. Have you got my point? Now there is one more question here. It took 1 hour to select these questions from question bank, and these questions are asked. There is circuit diagram here. 19 minutes चलो please चलो फिर sorry let me do next video.